Hey guys, here's a video on transformation of logs. So the general form for the transformations is y equals plus or minus a times the log base of b of plus or minus x minus h plus k on the outside. So just like normal, our plus and minuses are reflections. If it's in front of the a, then it's the x. If it's in front of the x minus h, then it's over the y. A as normal is just our stretch or compress. H is our left and right movement, but remember it's always opposite of what we think. And then K is our up and down. Remember, a log without a base has an implied 10, and each base has its own parent function. So no matter what, if you don't have to really focus on that beat. The parent function must go through the point 1, 0, and the asymptote, which is what it's going to approach but never touch, is x equals h. The domain will go from h to infinity, or if it's reflect over the y, so it'd have a negative in front of the x, it would go from negative infinity to h. Then the range is always negative infinity to positive infinity. Alright, so look at the first one. We got y equals log of x. So since this does not have a base, it's automatically base 10. So if I really wanted to, I could write in a little 10 right here. But it looks kind of ugly, so pick and choose your poison. I don't know. Alright, so it's asking us to graph the function and state the domain and range in the asymptote. But I also want to state the h and k just to help me out. So looking at this, I don't have anything with my x on the inside. So my h is automatically 0. Then I don't have anything added right here, so there's automatically 0. So our hk is 0, 0. So then our asymptote, as we said, is x equals h. So x equals 0. Our domain is going to go from our h, which is 0, to infinity. Awkward. Okay. And then our range is always negative infinity to positive infinity. Now when you graph this, it looks something like this. I want you to take special note that it goes through the point 0 or 1, 0. And then it's approaching this line right here, x equals 0, but it's never truly going to touch it. It's going to get as close as it can, but it's never going to equal it. Okay, and so this one is actually a parent function. All right, next one. We're going to state the domain and range of the transformation. Oh, and the transformation. So we got y equals log of x plus 3. So let's first do our hk. So h comma k. So again, we don't have anything added or subtracted from our x, so it's just going to be a 0. And then we got our k is 3. So what this is telling us is that when we're looking at the point 1, 0, the graph now is going to move to 1, 3. So you can look at the point 1, and then this k value is literally just telling you how far up or how far down you moved from the point 1, 0. Alright, now our domain. Our domain goes from h to infinity, so it's going to go from 0 to infinity. And then our range is always negative infinity to positive infinity. Now the transformation, so we got the plus 3 on the outside. That's the only thing that's different from the parent function. So it moved up 3. And we are done. Okay, if you need any help so far, go ahead and stop this, rewind, and rewatch what we've done so far. Alright, next one. State the domain, range, and transformation. So this is y equals log base 5 of x minus 4 with a minus 4 on the outside. So to start, our hk. We have a negative 4 with the x, but for h we always got to do the opposite, so it's going to become a positive 4. And then our k is right here, so it's going to be minus 4. So then if you're looking at the point 1, 0, it's now going to be at, it's going to be at 1, negative 4. Okay, now our domain goes from h, so from 4 to infinity. And then our range is always negative infinity to positive infinity. Sorry, my infinity signs look weird.
Mr. Fuller, if you're in the building, Mr. Fuller, would you please report to Admin North?
Alright, our next thing that we're going to have is our transformations. So since we have a -4 right here, let me switch to blue. We have -4 right here. We're going to do the opposite. So we think that we're going to go left because it's minus, but instead we're going to go right. So we're going to go right 4. And then we got a -4 right here, so we're going to go down 4. That down does not look like down, but it's down. So right 4 and down 4. That's our transformation. Okay, so far, if you have any questions, go ahead and stop and rewind back. Alright, next one. Y equals -2 log base 3 of x plus 3. So this one, we added in this little a value right here, which is what we haven't really had yet, but we'll get there in a second. So the first thing we need to do is our HK. So our H is going to be the opposite of +3, so it's going to be -3. Nothing added, so it would be -3, 0. Alright, domain. It's going to go from our H, so -3 to infinity. Awesome. And then our range is going to go from -infinity to +infinity. Alright, now let's look at our transformation. So the first thing that we have that we haven't had yet is this negative right here. And as we said before with the general form, the negative out front tells us it's going to reflect over the x-axis. Okay. And then the 2 right here, since 2 is greater than 1, it's going to stretch. Yep, go. ETCH. And then lastly, we got the +3 right here. So that means it's going to move to the left 3. So there's all of our transformations right there. Okay. Alright, next thing. So saying study the graph of f of x to determine the transformation that was used to create p of x. So looking at the point 1, 0, I want to go from the blue line to the red line. So going from 1, 0 to 1, 5, if you notice, we had to add 5. So no matter what, we're going to add 5 to our new equation. Alright, and then this is where things get a little bit different compared to our other functions. So in order to tell if it's a stretch or a compress, or if it's normal, like the exact same, we have to pick a point. So let's just say that this actually goes through the point, oh, I need to get a pen. Let's say the blue one actually goes through the point 3, 1. Let's say that that's truly there. Then we're going to go directly up 5. 1, 2, 3, 4, 5. And we're going to be right here. But if you notice, the red line doesn't go through our new dot. Instead, it's above it. So since it's above, that means it's going to have a stretch. And it's going to have, so that means your A is going to have to be greater than 1. So that's why your A for this one is 3. If the red line went below it, then it would be a compress. So you would have a fraction, less in between 0 and 1. And lastly, if it went through the blue line, then it would be identical, so we wouldn't have a stretch or a compress. If you have any questions on this one, feel free to ask your teacher or ask me, whatever. We can explain it to you. Alright, last one. The parent log function f of x equals log of x is translated 12 units to the right, vertically compressed by a factor of a half, and translated 25 units up. Now I want you to write the new equation. This new equation I am going to call, let's call it g of x. Okay, the first thing I need to look at, it's vertically compressed by a factor of a half. So that means I need to have a half on the outside. Then I have my log of, it went 12 units to the right. So we're going to think it's true, you think it's going to be x plus 12, but since it's the opposite, it has to be x minus 12. And then it went 25 units up. So plus 25 on the outside, and you are all done. Box your answer. Great. Turn it in. Okay. All right, that's all we have for transformations. If you have any questions at all, feel free to ask your teacher. Um, I don't know what more to tell you. It's basically just like every other thing that we've done. So again, if you need help, go ask your teacher, come ask me, and we'll be more than happy to help you. Hope you have a great day.